Okay. So activity 9 is all about transformations. Think of the word transform. When you were little, or maybe a brother or sister, did they ever play with Transformers? You know what that is? It was maybe like an action figure and then it turned into like a car or a frog or something like that. It's a transformer. That's what the toy was called. It means to change. Our activity 9 is all about transformations, changes. There are 4 ways that we're going to transform or change a figure. Today is an overview. When we get into 9.2, it's going to be translate, then rotate, then reflect, then dilate. Today is an overview, and then we're going to do each of the 4 individually after that. So let me go ahead and read what it says. Mr. Scott directs the Marching Cougars, the band at Chavez High School. He uses the coordinate plane to represent the football field. For the band's first show, he arranges the band in a rectangle that is 6 marchers wide and 9 marchers deep. So to keep himself organized, he uses the XY chart, this coordinate plane, so he can mark the people in the band. The band begins by marching down the grid in this formation. Then the marchers move apart from each other vertically while keeping the same distance between the marchers in the same row. Do you see how these pictures follow what I just said? The band begins by marching down the grid. Then the marchers move apart from each other vertically. You can see that happening here. It says transformation 1. That means change number 1. They moved down 6. Now how are they going to transform? Now they're going to move apart from each other vertically. Transformation just means to change. That third paragraph there, I'm right here. It says, the diagram shows the initial shape of the marchers and the 2 transformations that they undergo. There's that vocab word transformation, and it's over here on the right. Is this in your packet on the right also? Okay. Yeah. A transformation is a change in the position, size, or shape of a figure. To describe and classify a transformation, compare the pre-image of a transformation to its image. So pre-image before, image is after. Like when you look in the mirror, you see your image. You are the pre-image, and then you see the image, the after effect. Number 1, use your own words to describe transformation 1. Here it is in the picture. This is transformation 1. Use your own words to describe that. Got that done, Aiden? Okay. Something about everybody moved down 6. Or whatever own words you wanted to use. Number 2, compare transformation 1 to transformation 2. They didn't all go down 6 again. So describe the differences between transformation 1 and 2. say something like the first transformation, everybody just moved down. The second transformation, they moved apart from each other vertically. We're going to skip over number 3. And actually, we're going to skip the whole next page just for time. You could go through this. It talks more about the distance and how people are moving. But I think we'll get enough of the notes done if we just hop all the way to number 6. The directions here for 6, draw each image. So I gave you the pre-image. You're going to draw the image. Is it, oh shoot, did I say rigid motion yet? I think I forgot something. Sorry, go back. I forgot real quick at number 3. There's a pretty important vocab word here. Number 3, transformation 1 is an example of rigid motion. The next sentence tells you what that means. A rigid motion preserves size and shape. Do we know what preserves means? Yeah, like a preservative that you add to your food to keep it nice since it sits on the shelf for a while. What's a good preservative in food? Anybody know what people add to food to preserve it for a long time? What? You say wax? Yeah. Salt. Salt preserves it. Anyway, preservative means to keep. So rigid motion simply means I keep the same size and shape. So if we look up, was transformation 1 rigid motion? Did I keep the same size and shape? Go ahead and write rigid motion. Rigid, like it doesn't move very well. It keeps the same size and shape. Was transformation 2 a rigid motion? It didn't stay the same size and shape. It got bigger. So I would put not rigid motion. Now we can go ahead and jump to number 6. Draw each image, then we'll answer, is it rigid motion? We have not discussed anything like this before. This is called a rule or a function. If you hear those phrases, it just means like kind of like a formula. Here's what it means. It means you're going to take every x and you're going to do this to it. Add 3. Then you're going to take every y and keep it the same. I'll show you how to do that. Let's all start with point L. Please write down L. We'll write down the coordinates. The coordinates of L are 2, 5. Make sure when you guys write coordinates or points, please, that you put it in parentheses with a comma. That's the correct way to write a point. Next to L, I would like you to write L prime. It looks like L apostrophe. In math, we just call it L prime. Here's what we're going to do to it. We are going to take our x and add 3. Our current x is 2. Add 3, we get 5. Now take the y value and don't change it at all. Just keep it y. So it's 5. It stays 5. Please plot that point. 5, 5. And label it L prime. We don't want to call it L because we already had an L. But we want to tell people, hey, this is where L is going. That's why we call it L prime. Now, can you tell from the picture? All I had to do was just slide it over 3 in the x direction. Do we really have to write out the points every time to slide something over? No. So what you're going to do with m is you're also going to slide it over 3. 1, 2, 3. Call it m prime. Do the same for n. Take its current position, move it over 3 in the x direction. And do it for your last point, k. I've changed all of the points in the same way. Does this appear to be rigid motion? Did I keep the same size and shape? Okay, right. Yes, it is rigid motion. What do you suppose would have happened if this had said x minus 3? Exactly. It would have gone to the left. What do you think would have happened if it would have said y plus 3? Up. What about y minus 3? Down. Here's the rule. I'll say this a couple times. If you're only adding or subtracting, you are not required to write out all of the points. Unless on the test it says, hey, list them out, then you have to. But otherwise, you don't have to write out the points if it's just adding and subtracting. You can just slide it left, right, up, down. Let's look at part B. We are not adding, we are multiplying. So I'm going to require us to write out all the points. So please write out the coordinates for P, Q, R, and S. Do it on your own. Don't look up and copy mine. Got 1, 5, 3, 5, 3, 2, 1. Check to see that you have parentheses and a comma. That makes it a point. Above these points, I would like you to copy the rule, or what we call the function. So I just recopied kind of what it told me in the directions. Now let's apply that rule to every point. Please do not make this difficult. It is really easy. All you have to do is take your x and follow what it says. What does it say? Times 2. Take your y. What does it say? Times 2. So let's do that. Let's take our x and multiply it by 2. Take your y, multiply it by 2. Keep going. Every x and every y gets multiplied by 2. Now what are we going to do? Plot the points. Plot these new red points and label them. Is this rigid motion? No. Right, not rigid motion. Just kind of a heads up for next week. This one here, part A, is called a translation. Let's add that word, translation. It just means to slide, left, right, up, down. We got to be careful because there's two words that sound very similar. This word, translation, and the word transformation. Transformation means to change. This is one way you can change it. You can translate it, which means to slide. This one is called a dilation. Like when you get your eyes dilated, your pupils are getting way bigger. That's correct. So when things get bigger or smaller proportionally, it's a dilation. Does this stuff seem pretty easy? See how it's so different than what we've been doing? Very different. So doesn't matter what you got on your last test, this test could be an A. Number 7, write a 4 in each pre-image in number 6. Pre-image is the original. Put a 4 in the original, in the pre-image. Describe how the number would appear in each image. Well, if I have a 4 here, and I have to put a 4 here, the only difference is the 4 is moved to the right 3. Write that down. The 4 is the same size and shape. It's moved to the right 3. The 4 is the same size and shape. It's just moved to the right 3. Over here, the 4 here, it's not going to be the same size and shape. This 4 is going to be twice as wide and twice as tall. Write something about that. We've got 2 more. Number 8. Perform the following transformation. Before you start, I would like you to get an idea in your head of what it's going to look like. Based off of this function, think about what your answer is going to look like. Can somebody describe it to me? Left 2, up 1. I agree. Do we need to write out all of the points? No, we don't have to write out all the coordinates. We can just simply move it 2 in the negative x direction, so this way 2, and 1 in the y direction, so up 1. I'll show you how it's going to look. It's pretty basic. I'm going to take point A. I'm going to move it over 2 and up 1. Call it A prime. You're going to do the same thing for B. 2 to the left, up 1. Do that to every point. when I slide something around, should it stay the same size and shape?
Yeah.
Yeah. There have been times on tests where I give students a question like this and they end up with a triangle. And they're okay with that and they turn that in. That makes no sense that I can take a rectangle, slide it over and up, and suddenly it's a triangle. That won't happen. So if you see that, you're like, oh, I must have missed a point somewhere. Number 9. Perform the following transformation. Do I have to write out all my coordinates? Yes. My rule again, if you're just adding or subtracting, you don't have to. You can just slide it around on your figure. If you are doing something else, like multiplying or dividing, you have to write it out. So take a minute to write out your original coordinates. Here's what I got for my coordinates: 3, 2, 3, 8, 9, 8, 9, 2, if you went in alphabetical order. Now I'm going to recopy the rule, or what I call the function. We're going to apply that function to get our new points. Here's a piece of advice. I would do all of the x's first. I wouldn't do point A, B, C, D. Here's why. The x, according to this formula, is going to stay the same. So these x's are going to be exactly the same. It's easiest to just copy those down. Now the y's are going to get divided by 2. This y was 2, divide by 2, divide the next y by 2, and keep going. Easy, right? Very easy. Okay, plot these new prime points and make sure they're labeled. It's always good to ask yourself if it looks like a reasonable answer. Here's what I mean by that. Look up here. Does this seem reasonable for what happened here? Yeah, the x distance should not change. It should not slide over. It should not get farther apart. The y distance should be divided by 2, which looks like what happened.